today I'll talk about some of our recent work in the area of question answering over text and tables. And this is joint work with my students, Wang and Wang Han, and there are also other collaborators that are involved in this project. So often, I've been asking myself this question: what are the challenges of question answering research? So not too long ago, a few months ago, my student Wang Han was doing his PhD defense, and he was actually showing a system that he built over the summer at Facebook. So this was a multi-hop open domain question answering system, or MDR. And I was very eager to try out the demo. Normally students don't want to, have their advisors to try out their demo during the defense, right? So actually I gave it a try to ask this question: who is the president of the United States when Churchill was the prime minister of UK? Turned out that actually MDR system was able to give the correct answer, which I think is pretty remarkable because it is a very difficult question. And Google search didn't provide a correct answer, a direct correct answer at the time. And if you're interested in the MDR system that Wang Han created, you can go ahead and download the source code and play with the system. So how great his system? So that was basically the question I was asking myself. I was very curious about, what are the things that are still missing, right, from the state-of-the-art systems. So if we look at the current status of QA research, we can, ask, other type of questions, right? So very simple questions. For example, what is the second biggest city in California? And turned out that when I asked this question, the MDR system didn't give you the correct answer. But if you do Google search, it will give you the correct answer. And if you closely look at the Google search result, you will recognize that Google was actually pulling the answer from a table. So it was able to locate a chart that described the largest cities in California and ranked by population. And then it was able to pull the second row and locate the second cell, which is the correct answer to this question, San Diego. So in my opinion, if we really want to build knowledge-grounded NLP, whether it's dialogue or it's question answering, we really need NLU and NLG systems that are capable of understanding the heterogeneous representation of knowledge. For example, documents, knowledge graph, tables and charts, in image and even videos, right? So how would you be able to understand this heterogeneous representation, parse the question, generate the correct answer, and synthesize it and return the correct answer to the user? Okay, so that I think is a very important thing that we need to address, and it's a very important topic for the workshop as well. And when we talk about question answering for understanding the world knowledge, I would say there are a lot of work on tables, knowledge graph, and documents separately. But how would you be able to seamlessly connect all these different modalities and these heterogeneous representations? And I think that would be a very important thing to have, that you may actually need to use partial knowledge from different modality, but how would you be able to integrate and generate a correct answer? So that's a key item that we'll discuss in today's presentation. Like I said, when we talk about text-only QA and table-based QA, I think there are a lot of work in the last 10 years. When we talk about text-based QA, I think one thing that can quickly came to our mind is basically the reading comprehension task, that given a question, often will be able to generate a starting and ending span of the question of the answer that we're looking for. Whereas when we talk about the table-based or knowledge-based question answering, KBQA, this was also really popular, specifically, I think, in the last 7 years and 8 years. There were a lot of related data sets in web questions, how can we understand tables and how can we understand the question? Normally, what we do is that we parse this question into a semantic representation and we execute against this table to find the answer. So that's pretty much the current progress. And like I said, the semantic parsing approach was very popular, I think, in the last 5 to 10 years. And parsing this question into a semantic representation typically require some hand engineering work in terms of understanding what predicates that are involved and how can I construct a search space to be able to generate a correct logic form to basically generate the correct answer. Whereas the reading comprehension work, I would say, is more recent, starting mostly after BERT in the last 3 years, was mostly focusing on a neural representation learning that directly takes questions and paragraphs as joint input BERT system, and the output would be the start and end token. So this is very straightforward. There are no logic form, but also itself is kind of like a black box to give the answer. The question we're asking in this work is that can we closely integrate text-based QA and table-based QA? So instead of treating them separately, what if there are scenarios, right, that we may actually need to use partial information from the table to help us to guide the system to find the correct answer in different modality? For example, someone might ask this question: when was the runner-up song for Billboard Hot 2019 release? So for this question, if we look at the table Billboard 2019 year-end Hot 100 chart, that we're able to find the second one is Sunflower. It doesn't provide us enough information to answer this question. So we have to actually dig into the Sunflower's Wikipedia entry and then realize the song was released on October 18, 2018. So this is certainly challenging because by just looking at the text data, there's no way you can get a correct result. And by just looking at the table, you don't have enough information. So how can we teach machines to reason in this different modality to be able to give the answer? I think that's a very important research direction that we need to think about now and also in the future. All right, so the other thing I want to mention is that the symbolic and semantic reasoning approaches using a neuro-symbolic representation itself, it is a very important direction because there are pros and cons for each of these two very different school of thoughts, right? And on one hand, sometimes we do need to be able to parse this question correctly. On the other hand, you do want to have very representation about the text and the table to be able to answer this kind of question. So there are many questions and you can explore these questions on our HybridQA website. All right, so how does HybridQA break the boundary? Like I said, a very important thing we did when we created this data set was that we actually linked the Wikipedia abstracts, right, together with these different entries. So if someone asks this question, well, in addition of using this table, that systems can also utilize the underlying Wikipedia articles to get an extended review of where the answer might be. So when we create this data set, we took this table and together with this collection of Wikipedia articles associated with the entries in this table, we send them to Amazon Mechanical Turk so that the Turkers can actually take a few iterations to generate the QA pairs. And we have very complicated model checking and human checking process to make sure the quality of the question answer pairs created by the Turkers were high. And we also ask the Turkers to ask questions that you must utilize heterogeneous representation to answer this kind of questions rather than very simple questions that can be answered in the text or table alone. At the end, we generated a HybridQA dataset, and the HybridQA dataset for each question is paired with a table and an average of 44 relevant passages. So you can see it's not one or two, but still a relatively large number of passages. So towards the end, we got about 70K question answers, and these pairs were together with 13,000 tables, and about 15-70% of the answers are in a passage, 43% are in a table. But however, again, it doesn't mean that you can directly find an answer in one modality. You do need to have the capability to reason in both modalities, right, to be able to give the answer. There are a lot of interesting characteristics about this data set. For example, the table aspects, usually you can compare, you can have filtering operations, and there are several other operations. And for text, it's mostly span selection and semantic matching. So you must be able to build a system that can do well in both cases, so such that you'll be able to get good result on this data set. So one baseline system that we built earlier was the symbolic reader approach, that first we narrow down which cell that we should be looking at, and then we look at a passage. For example, the first step is to link the top K rows with the question, and then we rank the top row and also the cell. Finally, after we located the cell, then we read the linked passage to give the correct answer. So here's one example that we first find related cells, the rows with the row, then we perform ranking, use a birth ranker, then we locate this particular row, and then we also have a birth ranker that tells us which cell is more likely to be the correct cell. And finally, after we located the target cell, then we take the target cell together with the Wikipedia articles associated with the entries in this cell to send it to the model and see if we can treat this a reading comprehension task to give us the start and end span of this question. So we did a couple of experiments to validate this baseline. So we tried the table-only approach. That didn't work very well. Just directly select the answer cell. That can give us about 8% exact match result. Using text only, we're able to get 20%, but again, we do need to utilize both table and text. And in this case, we get 44% with our joint model that links both table and text that I described earlier. Finally, I want to mention that for this data set, the human performance is actually pretty high, it's 88%. So it's still very challenging. Right now, I think there were some improvements. I see many participants join this task in the last year. So they were able to push the numbers slightly higher, but still they are very far away from the human performance. And we also analyze different type of errors. We look at whether the performance on the in-table type of answer is good, comparing to in-passage answers, and compare it with this kind of numerical questions. We've been also looking at the stepwise error analysis in terms of reasoning step, and see if that actually hurts the performance. Some of our recent work along this line I want to refer you to includes this ICLR paper from this year that Wang who did his internship at Google AI with Wang and colleagues. So this particular work extended the HybridQA work because it's taking this HybridQA data set to the open domain setting. So if you want to think about HybridQA as the reading comprehension version, right, of this table and text QA task, then the open table and text QA or OTT QA task is the open domain setting, meaning that we'll have to decontextualize this question. We'll have to recollect open domain question answer pairs, And then we have to add new depth and test set questions on these newly brought tables that basically help us to remove the bias in this retrieval process that I'll tell you more about. And finally, this data set was much larger because, like I said, it's an open domain setting that systems, they do need to retrieve the questions and answers, not just by looking at the given set of tables and text, but you do need to get the tables and text using information retrieval approaches from more than 400,000 candidates of tables and 5 million candidates of passages. So this is definitely much more practical, but also much more difficult setting. All right, so like I said, OTT QA dataset is also available for you to download and actually play with it. Like I said, it's very related to HybridQA, but the main challenge in this case is that you do need to build a system that is efficient and also is effective in getting the correct documents and tables. So this would be more realistic because in this case, when someone asks this question, what is the home stadium of LeBron James during the NBA season suspended by COVID? Well, you will have to first find the table and the documents, right, to be able to get the correct answer. So when we are attacking this kind of difficult question, like I said, one thing now we need to build is an additional retrieval module. So the retrieval module will actually need to help us to identify, should I retrieve a text document or should I retrieve the text and the table or maybe multiple tables, right? And then we need to integrate the retrieved tables and text and then perform reasoning to give the correct result, right? So it's actually a fairly difficult thing to do because we need to integrate and you have to look at large collection of examples. So the retrieval reader framework proposed by Wang will need to address the issue of how can we correctly identify the most relevant 5-minute passages and also the most relevant tables from the 2 million collection, right? So that's very difficult. So for the retrieval, you can think about we're using a neural approach to link the question and the passage, right, together with the table and to select the top K answer. Once we get a top K answer, then again, we can use the same reading comprehension approach that we use in HybridQA to generate the correct answer. So this is the basic philosophy. And again, we also need to think about the baseline. So in this case, we've been looking at multi-hop retrieval baseline that would basically use the BERT as the encoder to encode the source documents and also the tables. Then again, we have a BERT encoder with the question. So this is kind of like a relatively standard approach of this neural dense retrieval method that encode this documents and tables into indexes, and these are the dense index encoded by BERT. And then you can do the same with the question. And the next would be try match, right? This encoded question using the BERT vector together with the documents, right, encoded also by BERT. Then we'll be able to find, well, maybe that's the top one, here's top two, and top three may be, a passage, right? So in this case, we'll be able to get a whole bunch of documents and tables, and basically we just need to find a top K. And now once we get this top documents and also top tables, what do we do? Well, one thing we can do is to build a graph representation, right? To use the graph encoder to encode the top K answers. And then with the graph encoder, well, this can also allow us to model the relationship, right, between entities and between tables and documents. Then with the additional information, we are now able to model the complex relationship, right, among all these different documents and tables, so that this will help us to correctly find the answer. like I said, one of the major challenges we run into in this particular project was that efficiency was a big consideration, because you can imagine that if we don't use an efficient module, that we use the traditional Google BERT model, then it is very slow, right? And it's very dense, because we need to consider all these different pairwise interactions between flows and also the documents, right? And if you imagine that for the Google BERT model, that you may actually have K squared, B squared, where K is the number of retrieved blocks and B is the average length, right, of per block. So in this case, this would be very slow because that would be almost impossible to feed everything into the memory. Whereas Wang's approach in this case is taking a Sparse-Attention approach to look at local and global integration, that we model the global information, but also trying to take a more energy efficient and memory efficient approach. And in this case, the complexity is only KB squared. So in this case, it's not that difficult for the regular GPUs to handle. And it's much faster and also more memory efficient. Meanwhile, even if we are using Sparse-Attention, we're still able to model the global context. We're still able to model the relationship among different entities in a graph structure. So the experimental result, I think, was very promising with this particular OTDQA paper. So BM25, many of you know, is actually very strong traditional IR baseline that for deep learning approaches, if we don't have enough training data, in many cases, we wouldn't be able to beat BM25. But in this case, you can see the best BM25 baseline is 9.9. And we also directly apply a multi-hop BERT approach from our ICLR paper from 2020. That was not trained as domain, so that also didn't work super well. But with the baselines, we'll be looking at a single hop BERT approach, and the multi-hop Sparse-Attention, and finally single hop Sparse-Attention approach. We're able to get a performance to about 27 or close to 30%, which is pretty good result consider the extremely difficult OTDQA setting that requires systems to understand not just text, but also tables, but also being able to retrieve the correct tables and text that contains the answer, and then does reading comprehension. So this open domain setting, OTDQA, is definitely much more challenging than HybridQA. And we also did some experiments with regarding the efficiency, and we found that single hop retriever is also much faster than a multi-hop retriever, and the Sparse-Attention reader is also twice as fast as the BERT reader. So to conclude today's presentation, I want to say that we really need to think about more realistic and more challenging settings for question answering. And one thing I definitely noticed in the last few years is that question answering, still we don't have good systems that can always give good answers. And part of the reason is that we always miss out the answers that is presented in a different modality. So if you look at the text only, we're always missing out. Whereas if you look at documents, even you're looking at financial documents, or you're looking at scientific documents, or even Wikipedia data, and sometimes in the news articles as well, that tables are pretty much everywhere. So how can we teach machines to understand tables and the text and being able to answer questions, right? That needs joint reasoning between tables. I think this is a very practical, but still a very challenging problem in NLP. So the HybridQA data set is something that I think is as the first step towards this problem. And the second part of the talk, I introduced OTDQA, which is more practical setting, that is also more difficult setting that requires systems that first use information retrieval or other approaches to identify the correct documents and the tables, including the results, and perform reading comprehension over those texts and tables, right, to reason and provide the correct answer. So in short, OTTQA is a more practical setting, but it's also a much more challenging setting in open text and table question answering problem. Again, I want to mention that for HybridQA, the website is here, and we still have the challenging going. From the back end, you can see there were a lot of teams participated very recently and also earlier this year. So if you're interested in this challenge, it is still open. You can download Dataset and play with this dataset. For OTTQA, this is more recent. So this was just released this year at ICLR. So OTTQA, I think, I personally like it very much because it is more closer to the reality. But on the other hand, it's also much more difficult to tackle because you also have to work on the error component. But we also have the website up, and the challenge is also just launched not too long ago. So you're welcome to try out HybridQA or OTTQA and see whether you're able to build a system that can achieve reasonable result for question answering or tables and text. Finally, I want to thank all of my students who contributed to this work. Again, all of the software data sets I discussed in this work, they were released from the websites that I showed you earlier, or you can just Google HybridQA or OTTQA dataset download, and you should be able to find the dataset and the starting code. I want to thank all of the sponsors for this work, and I'm very happy to take any questions that you may have.